So we're going to start by talking about chylomicrons. Generally speaking, triacylglycerols are the major dietary lipids, and they're digested in the lumen of the intestine. The initial digestive products, free fatty acids and 2 monoacylglycerols, are reconverted into tags in the intestinal epithelial cells and packaged into what is referred to as chylomicrons. So our general structure of a lipoprotein is shown here, and chylomicrons constitute the largest of the lipoproteins. They contain cholesterol, fat-soluble vitamins, in addition to their major component, which again is dietary triacylglycerols. The major apoprotein associated with chylomicrons as they leave the intestine is ApoB48. So here we can see a comparison of the synthesis of chylomicrons in the intestine versus the synthesis of VLDLs in the hepatocyte. What you'll notice is that the synthesis of our apoproteins in both cases occurs on the rough ER. In both cases, the apoprotein, in the case of chylomicrons, again ApoB48, and in the case of VLDLs, ApoB100, then enters into the smooth ER and is packaged with our lipid components, both triacylglycerol as well as cholesterol. Here you can see the nascent chylomicrons will then undergo several modifications in the Golgi before being released from the cell. So in the case of chylomicrons, these are released into the lymphatics through the chyle and will then enter into the bloodstream through the thoracic duct. This is in contrast to VLDLs released from the liver, which are delivered directly into the bloodstream. So if we look beyond the process of chylomicrons entering the lymphatics and into the bloodstream, you can see that we now have a nascent chylomicron. It has our triacylglycerol, our cholesterol, as well as our apoprotein ApoB48. This nascent chylomicron needs to have an interaction with HDL before it's fully matured. This interaction with HDL in circulation involves the transfer of both ApoC and ApoE onto the chylomicron. And both of these apoproteins will play key roles in the maturation of the chylomicron. So first of all, ApoC2 is required for the activation of lipoprotein lipase. And lipoprotein lipase is an enzyme attached to the proteoglycans in the basement membranes of endothelial cells that line the capillary walls. ApoC2 interacts with lipoprotein lipase to activate the enzyme. The active enzyme will then hydrolyze the triacylglycerols into glycerol and free fatty acids. These free fatty acids are taken up by extrahepatic tissues and then restored as triacylglycerols. So it's also important to note that lipoprotein lipase is stimulated by insulin. So after a meal when insulin is high, insulin will induce the synthesis and secretion of lipoprotein lipase. This is important so that after a meal, when triacylglyceride levels are high, lipoprotein lipase has been upregulated to facilitate the hydrolysis and subsequent storage of fatty acids from our circulating chylomicrons. So the portion of the chylomicron that remains in the blood after lipoprotein lipase action is referred to now as the chylomicron remnant. You'll notice that the remnant has now lost ApoC, and it has returned this back to the HDL. So now ApoE will mediate the reuptake of the chylomicron remnant into the liver. And there are 2 ApoE-dependent receptors on the liver that can facilitate this reaction. The first is this LDL ApoB100E receptor, and the other is the LRP, or LDL receptor-related protein 1. You'll also notice the enzyme here, hepatic lipase. This enzyme has 2 roles, as it acts as a ligand to facilitate remnant uptake, and it will also hydrolyze any remaining triacylglycerol and phospholipid in the remnant itself. Once inside the liver, you'll notice that the chylomicron remnant is broken down into its key components. So let's finish with this clinical example of A beta lipoproteinemia. And in this clinical presentation, individuals cannot form any lipoproteins that contain ApoB, and this causes lipid droplet accumulation in both the intestine and the liver. Remember, the intestine is going to be our location of chylomicron synthesis, which contain ApoB48, whereas our liver is our location of VLDL synthesis, which contains ApoB100. And so in these individuals, what is the level of plasma triglyceride and cholesterol? So as we talk about cholesterol and lipid transport, it's important to keep things clear, and that is the tissue concentration of lipids and the circulating concentration. And so in this case, the lack of ApoB proteins results in a lack of production of chylomicrons and VLDLs for lipid transport. And therefore, the triacylglycerides are now retained in the tissues. This results in very low levels of plasma triglycerides in blood and also very low levels of total cholesterol.